Hello everyone, so in this video let us talk about a easy level problem from LeetCode. The problem name is valid mountain array. As you can see, you are given an array of integers ARR, return true if and only if it is a valid mountain array. Now what is a valid mountain array? As you can see, the mountain is like this. It first goes strictly increasing and then strictly decreasing. So you just have to check that if the array that is given to you is a mountain array or not. It should be strictly increasing till a certain point. Like the point doesn't matter, but it should be strictly increasing for a certain point. Then it should be strictly decreasing. The length of the array should be greater than equal to 3, and it should be strictly increasing. That's the whole thing. So it's pretty much simple. You just start from the very first and check that the next element should be greater than this. The next element is greater than this till a certain point. Okay, you have to ensure that it should be increasing till a certain point. After that, when the certain point decrease, like when it reaches a certain point, then it has to decrease. So decrease means that the current element for the ith element, the next element has to be smaller and the smaller and so on. Okay, and then it reaches the very end. So the edge case can be like it is only strictly increasing or only strictly decreasing. Then that is false. Let's say we keep on increasing. Okay, and then we reach the very end of the array. The array is like this. The first element is 1, 2, 3, 4. It is strictly increasing and it reaches the very end. Then that is bad because I have to somehow have some element that is decreasing as well. Okay, only one element can also be decreasing, but it has to have some decreasing element. It cannot be just totally increasing. Also, it cannot be just totally decreasing. There is no increasing part. There's only decreasing part. That is also not valid. Okay, and should be strictly increasing. It should not have a constant numbers. That is the thing that you have to ensure that the next element should always be greater than on the left hand side, and always the next number should be smaller than the next number in the decreasing out. Okay, that's the only thing that you have to just check out. Nothing much complicated itself. Let's check out here in the code part now. So I hope you understand the actual thing part. So what we have done here is that we have the length of the array and the ith element we are iterating over, which is denoted by this variable that is I equal to 0. Then what we have done is that we have done a while loop. So we have done a while loop while I is less than n minus 1, not n, I minus 1, so that we can compare I and I plus 1, the next element. It will be first increasing. So the I plus 1 should be greater than I. Okay, so if it is keep on greater than, then we increment the I that, okay, this is fine. This is keep on incrementing. Then this is a while loop that will first go and find till we are going towards the uphill and finding out the strictly increasing part. Whenever it reaches this condition doesn't match, this while loop breaks out, we come out. Then we have to ensure that we haven't reached the very end, that is n minus 1, or we haven't started at all. If there is no part that is increasing, or we have reached the very end, then that is false. That because we should have at least some increasing part. We should not get to the very end. It should not be all increasing, or we should not have at least no increasing part. So if that any of the case met, then it is false. Else now we have reached the very top, that is I has some value, that is the increasing part. Now we have to check the decreasing part. So the same code, but now a of I, as you can see, has to be like the ith element should be greater than the I plus 1, so that it is decreasing part. Now it is decreasing. So now again we'll keep on decreasing, and in the end we have to check that after all the decreasing part as well, we have reached the very end of the array. Not that we have some decreasing part or like this condition met. Like this condition will always fail when we have when we don't have strictly decreasing. If we don't have strictly decreasing, it will fail. But like this will come out of this while loop. But you have to ensure that whenever we come out of this while loop, we have a mountain that is made. So which means that the I must have reached to the very end, that is n minus 1. If this condition, that is just a boolean expression, it returns true. If I is equal to last element, that is n minus 1, then only it will return true that we have completed a complete valid mountain array, or else it will return false. We can return false from here itself or here itself. Okay, that's the complete logic on the code part for this particular problem. If you still have any doubts, you can mention in the comment box of this particular video. I will be happy to answer all your queries. I will see you in the next one. Till coding, and bye.